robot just walked past me, and it moved like a human. Inside this factory, machines are building machines that think, see, and learn. What you're about to witness will change everything you thought you knew about the future. This is Tesla's Optimus Factory. Right now, behind these walls, the most advanced humanoid robots on Earth are being assembled. Every 45 seconds, another Optimus comes to life. But here's what nobody's talking about: the process that makes these robots move, think, and act almost human. I'm taking you inside Tesla's most secret facility. For the next 15 minutes, you'll see the complete journey, from raw metal to walking, thinking robot. No secrets hidden, no steps skipped, just pure innovation. By the end of this documentary, you will understand exactly how Tesla transforms basic materials into machines that could work alongside you tomorrow. And if you're fascinated by the future like I am, hit that subscribe button, because this technology is evolving faster than you think. Welcome to Gigafactory, Texas. This massive complex covers over 10 million square feet. But deep inside, there's a section most people never see: the Optimus production line. Security is tight. The technology here is years ahead of anything public. Everything you see is orchestrated by artificial intelligence. Over 300 robots building robots. The irony isn't lost on anyone here. This factory operates 24/7, producing what Elon Musk calls the most important product Tesla will ever make. Tesla's goal? Produce millions of Optimus robots per year. Not thousands, millions. Each one designed to handle tasks humans don't want to do. Repetitive, dangerous, or physically demanding work. But first, they have to build them. Let's follow one Optimus from start to finish. What you're about to see is the actual production process, step by step. This is where metal becomes motion, where circuits become consciousness. It starts here, with aluminum alloy sheets and carbon fiber composites. These aren't ordinary materials. They're aerospace grade, designed to be lightweight yet incredibly strong. The same materials protecting astronauts are now building humanoid robots. Precision laser cutters slice through metal with microscopic accuracy. We're talking tolerances of 0.1 millimeters. Every cut is programmed by AI to minimize waste. What would take human workers hours happens in 90 seconds. Now watch this. Robotic arms assembling the skeleton. This is Optimus's frame, his foundation. 28 individual pieces joined together with perfect precision. No welder, no human hands. Just machines executing thousands of calculations per second. Here's where it gets interesting. Optimus has 40 electromechanical actuators. These are essentially its muscles. Each joint can rotate, bend, and respond with human-like fluidity. Installing them requires absolute precision. Pause for just a second. If you're finding this fascinating, drop a comment below telling me which robot technology you want to see next. Your suggestions directly influence what we cover. And yes, that subscribe button, it helps us go deeper into factories like this. Before moving forward, every actuator is tested. Torque, speed, durability, all measured in real time. A single faulty joint could compromise the entire robot. Quality control isn't optional here. It's embedded in every stage. Look at these hands. 11 degrees of freedom per hand. That means Optimus can grip, pinch, rotate, and manipulate objects almost like you can. The hand alone contains 27 precision components. This is mechanical engineering poetry. Now, they're applying sensory layers. Thousands of microsensors embedded in synthetic skin that can detect pressure, temperature, and texture. When Optimus touches something, it feels it, not emotionally, but physically with data. This compartment holds Optimus's brain, a custom-designed AI chip running Tesla's neural networks. The same technology that powers full self-driving in Tesla cars now controls bipedal movement, object recognition, and decision-making. 8 cameras strategically positioned around the head and body. No LiDAR, just cameras and AI, exactly like Tesla vehicles. Optimus sees the world, processes it, and reacts, all in milliseconds. Vision is its primary sense. The battery pack slides into the torso. A 2.3 kilowatt-hour energy cell providing up to 8 hours of continuous operation. It's designed for quick swapping. When one Optimus needs charging, another battery slides within 2 minutes. All this computation generates heat. Tesla engineers integrated a liquid cooling system, similar to what's in their electric vehicles. It circulates coolant through channels in the frame, keeping the AI brain at optimal temperature. Aerodynamic body panels attached next. These aren't just cosmetic, they're functional. They protect internal components while giving Optimus a clean, approachable appearance. Design psychology matters when you're creating machines that work with people. Inside Optimus, there are over 3 kilometers of wiring. Every cable is routed through channels designed to flex with movement. Bad cable management in a humanoid robot? That's catastrophic failure waiting to happen. Walking on 2 legs is incredibly complex. Humans learn it as toddlers. Robots need precision calibration. Gyroscopes, accelerometers, and pressure sensors in the feet constantly adjust balance. This calibration takes 47 minutes per unit. This is it. First power on. Watch the eyes illuminate. Systems boot in sequence. The AI runs diagnostics checking every sensor, every actuator, every circuit. It's like watching something wake up for the first time. Seeing this process is incredible, right? Make sure you share this with someone who's as obsessed with technology as you are. And seriously subscribe. We're going inside more cutting-edge factories that most people will never access. Let's talk about what makes Optimus actually intelligent. The AI isn't pre-programmed for specific tasks. Instead, it learns through neural networks, pattern recognition, trial and error, continuous improvement. It's not artificial intelligence. It's adaptive intelligence. Tesla feeds Optimus millions of hours of video data. Humans walking, picking up objects, navigating spaces. The robot studies movement patterns and replicates them. Every Optimus shares learning with every other Optimus. Collective intelligence. When Optimus sees an object, it doesn't search a database. It predicts what that object is, how heavy it might be, how to grip it, all in real time. We're talking 36 trillion operations per second in that AI chip. The sensors aren't just collecting data, they're creating understanding. Temperature sensors prevent overheating. Pressure sensors prevent crushing objects. Vision sensors map 3D space. Together, they create environmental awareness. Here's what's revolutionary. Optimus makes decisions. Not conscious decisions, but calculated ones. If the optimal path is blocked, it finds another. If a task requires tool selection, it chooses appropriately. Autonomy through algorithms. Now we enter quality control. This section is critical. Every Optimus undergoes 50 different tests before it leaves this factory. Failure rate? Less than 0.3%. That's better than most electronics manufacturing. Test 1, mobility. Optimus walks across uneven surfaces, climbs stairs, maintains balance on moving platforms. The AI adjusts foot placement 200 times per second. What looks smooth is actually thousands of micro-corrections. Test 2, object manipulation. Picking up eggs without breaking them. Sorting components by size. Threading a bowl. These tests prove precision and control. A robot that can handle fragile items can handle nearly anything. Test 3, endurance. Continuous operation for 8 hours straight. Temperature monitoring. Battery drain analysis. Joint wear assessment. If it can survive this, it can survive real-world deployment. Test 4, safety systems. Optimus must detect humans within 2 meters and automatically slow movement. If unexpected contact occurs, emergency stop activates within 0.2 seconds. Safety isn't an afterthought, it's foundational. Before shipping, Optimus receives the latest software version. Over-the-air updates mean every robot continuously improves. The Optimus delivered today will be more capable 6 months from now through software alone. Let's address the elephant in the room. Humans versus robots. This isn't a competition. It's a collaboration. Let me show you what I mean. Humans excel at creativity, emotional intelligence, complex problem solving, and ethical judgment. We innovate, we empathize, we imagine possibilities that don't exist yet. Robots can't replicate that. They augment it. Robots excel at consistency, precision, endurance, and operating in dangerous environments. They don't get tired. They don't need breaks. They perform repetitive tasks with perfect accuracy. That's not replacing humans. That's freeing humans. The future isn't human or robot. It's human and robot. Factories where robots handle physical labor, while humans oversee quality, innovation, and strategy. Construction sites where robots lift heavy materials, while humans design and create. Imagine Optimus in warehouses, reducing worker injuries from repetitive lifting. In elderly care, providing mobility assistance. In disaster zones, navigating dangerous areas humans can't safely reach. This is practical technology with humanitarian applications. Critics worry about job displacement. History offers perspective. When ATMs arrived, people feared bank tellers would disappear. Instead, banks hired more tellers for customer service roles. Technology creates different jobs, often better jobs. The key is education. As robots handle manual tasks, humans need training for oversight, programming, maintenance, and creative roles. The transition requires investment in people, not just machines. Let's look ahead. In manufacturing, Optimus could enable 24/7 production with zero workplace injuries, faster output, higher quality, lower costs. That means more affordable products and competitive advantages for companies that adopt early. In healthcare, imagine Optimus assisting surgeons with steady, tireless precision, helping nurses with patient mobility, sterilizing environments perfectly, not replacing medical professionals, enhancing their capabilities. Space exploration gets interesting. Optimus could build habitats on Mars before humans arrive, repair satellites in orbit, handle toxic materials on the moon. We're looking at robots as humanity's advanced team for cosmic expansion. Tesla projects mass production by 2026, initial units for internal testing, and select partners. By 2030, they estimate millions in operation globally. The price target? Under $20,000 per unit at scale. That's cheaper than most cars. If this documentary opened your eyes to what's possible, help others see it too. Share this video. Subscribe to this channel because we're tracking this technology as it evolves. Comment below. Would you want an Optimus in your workplace or home? We're witnessing the early steps of a transformation that will define the next century. Not robots replacing humanity, but technology elevating what humans can achieve. The question isn't whether this future is coming. It's whether we're ready to shape it wisely. Inside this factory, the future walks on two legs, sees with digital eyes, and learns with silicon minds. But the real power? That belongs to humans who designed this, who built this, who imagine what comes next. This is just the beginning. And the best part? You're here to witness it. Thanks for watching.